Looking at the effect that various electromagnetic energies have on these molecules in the atmosphere will help us understand which are greenhouse gases. So this molecule is nitrogen, and nitrogen, when it's hit by visible light, we'll see, you gotta turn this on. Nothing happens when nitrogen's hit with visible light, and nothing happens when nitrogen N2 is hit with infrared or heat. So this would be incoming from the sun's radiation or outgoing. Nitrogen does not respond to infrared or visible light. UV doesn't even break that bond. Now let's switch it to oxygen. So this is oxygen O2, and SPECT does not respond to visible light. The bonds are just unchanged, as well as for infrared or heat. And so this is either incoming radiation from the sun or outgoing radiation contains infrared, and oxygen is unchanged. Let's see what happens with UV, ultraviolet. So oxygen, not affected by UV either, has a double bond, so not easily broken there. Look at carbon dioxide. This is one of the known greenhouse gases. We have carbon dioxide, methane, water, and ozone we're going to test. And so this is first carbon dioxide when it's hit with visible light. No changes. But let's switch to infrared. Slow this down a little bit. So you saw that vibration, there's bending and stretching that happens with carbon dioxide molecule because you can have bending and stretching around that central atom. It has a more complicated shape than N2 and O2, which is just a linear. This is linear but has this possibility of turning into a V shape. So let's look at that again. So that can turn into a V shape, which temporarily, this V shape temporarily absorbs heat, and that's heat coming from infrared, and then when it returns to the true linear shape, releases that heat to the atmosphere. So this is how carbon dioxide is a heat-trapping molecule. So let's look at that some more. So that's absorbing heat and then releasing heat at every time it goes back to the straight, the linear. So what happens when it's hit with UV? Nothing there. And this is still carbon dioxide and carbon dioxide with microwaves. Nothing there. So looking at the water molecule here, so this is H2O. It has that bent V shape, so this is the upside down V here. And first let's see what happens when water is hit with visible light. Nothing. And then infrared. So this is switching to infrared. Okay, slow it down. So the water molecule already has a V shape, and every time it's hit with infrared and bends or stretches, this causes hydrogen atoms to become closer together. That's a higher energy version, and then when this snaps back to the original V shape, it's a lower energy version. So in that process, the water molecule temporarily absorbs the heat energy from infrared and then releases it. So this is a heat trapping molecule. And microwaves for this water molecule cause the water molecule to rotate. So we'll get to this, and I've been mentioning this here and there, is that microwaves cause certain molecules, and water is one of them. Microwaves cause polar molecules to rotate. So next up is methane, so that's CH4. Methane is 23 times more heat trapping than carbon dioxide. Even though carbon dioxide is the most common greenhouse gas, methane is actually more potent. It's just that there's less methane being generated. Carbon dioxide we know is generated from all the combustion reactions. Methane specifically comes from natural gas. It is natural gas, but it comes from agricultural sources, which we'll talk about in nutrition chapter. But let's first see what happens when methane is hit with visible light. Okay, nothing, we would expect that. And then infrared. So infrared causes a lot of bending and stretching and wobbling, and every time there's bending and stretching, that is heat absorbed in there, infrared energy, and then as the molecule snaps back to its original tetrahedral shape, this releases heat. So methane is another heat trapping molecule. So this is infrared, trapping heat in the atmosphere. Let's see what happens for UV. So UV, not doing anything there as far as bending or stretching, eventually would break a bond. And microwaves don't do anything to methane. Microwaves only cause certain molecules to rotate. Okay, so let's take a look at this one, which is ozone. So this is O3. This is an oxygen with a double bond and a single bond. This has the same V shape as water, so you can take a guess what you think might happen as far as being hit with infrared or visible light. So first, visible light, let's take a look at that. This is visible light, doesn't do anything to the ozone molecule. But infrared, okay. So every time the infrared causes bending and stretching of that V shape to a more extreme V shape, that's energy absorbed, that's infrared absorbed, and then as this goes back to its original less bent V shape, less bent, then that heat that was absorbed will be released. So this is another heat trapping molecule that's a greenhouse gas. So this is infrared. We know what UV does for ozone, causes ozone molecule to break that single bond. Let's reset that. Okay, and that happens up in the stratosphere. So let's see what microwaves do. So microwaves cause ozone molecules to rotate because ozone is a polar molecule, just like water